regarding to the process management. Anyhow, this is the most important chapter of the entire semester, including the project. Okay, so please spend more time to understand what is the process, how to create, and how to manage the process. Then followed by the chapter 4, if I have a time, but chapter 4 is for thread. It's a special case of the process. It will be difficult to understand the thread. Okay, then between them, I'm going to have a quiz today. Okay, I don't know when, but once I finish the chapter 3, we will have the quiz. So be ready for the quiz. The only thing you need is any connected device. It doesn't matter whether you are using the cell phone or the laptop. Okay, then I'm going to a little bit explain the exercise lab. Maybe the GA will give more information about the project during the exercise lab, but I'm going to give this is exercise lab on Wednesday, but during the exercise lab, he will give the more information, maybe this week or maybe next week. During the exercise lab, he will give the more information about the exercise lab programming assignment. Okay, so that's the reason I put the Unix programming 1 and 2 earlier, because those are required to finish the first part of the project. Okay, so any question before we start? Okay, so to speed up, I'm going to use the slide. So this time, this is what we discussed the last time. To create the process, here's the first process. By the way, who created the first process? The kernel itself should know how to be allocated once the BIOS program point out the location of the operating system, and the operating system is the operating system image that has the starting the program. That is the kernel. Kernel should know how to be allocated on the memory and what will be copied using mostly assembly language or the C or C++ language. Even C or C++ language can be converted into the assembly. Then that will be the first process. Once the kernel process is started, as we have seen before, it will be there will be the number of children processes. So we are talking about this part, how to create the processes. Okay, as a descendant of the kernel. To discuss about this kernel, we need to know how to build. Mostly nowadays, do you remember the long history of the family? Okay, family history of the Unix. Those are some of them are newly built. Really, it's a new kernel, new process, the new program, but most of them are based on the previous one, which means if you have the new idea of the CPU scheduling, okay, you can add the CPU scheduling algorithm to the existing kernel, then it will be the new version of the kernel. To do that, each operating system provides the special program to rebuild your kernel. Okay. However, in this class, we are not going to, every semester I try to offer one more exercise lab to rebuild the kernel, but fail. Maybe the next semester, definitely I will prepare. But if you are interested to rebuild your kernel, then you want to make your own version of the operating system, why don't you take a look at the textbook first, and each operating system provides the special program to rebuild, which means compile the existing kernel. Okay, so you can make your own version of the kernel. Then after that, the last class we talk about how to create this child process. Basically, two steps. One is fork, the other one is exe. The main job of the reason why we separate the two steps to create the process is the fork. Basically, find the available resource. Okay, so which means this is the process at the memory, and the first current process is running. Then once you submit the fork, it will some part of the memory will be allocated. If you cannot find this available resource, it will be failed. We will see the later one. At this time, so for example, this is the bash shell. Text part is the number of instruction for bash. Then when you successfully fork the process, which means this resource is created. However, bash shell, this text part will be shared with the parent, which means it's exactly same, identical. Okay? It's the parent and child process are the same. They are sharing the same resource, same global, the variable, same thing. Okay? It's the exactly same thing, same the code. But simultaneously, they will process their own code. I will explain the more detail. Then, once exe is completed, exe means, so for example, this bash shell start the ls command, list the file. There will be the binary code executable file for ls, the bin/ls. This is the program, binary program. Somebody compile, then mostly such a ls or the dir or such a command are provided by your operating system or your shell program. Okay, then the instruction of this one will be loaded into this process, child process. Then the child process will be separated from the parents. At that time, there's one more, the system library that we learned. Wait, the parent is waiting for the termination of the child, which means while this ls command, for example, it takes 10 minutes to list up all the file. Suppose that, okay, supposing 10 minutes. During that time, during the 10 minutes, the parent process is not doing anything. Okay, just wait the last instruction. If last instruction of ls is completed and informed to I'm done, then the process state will be terminated. Then this parent process is going forward, next and next instruction. Okay, so that is the way. Okay, however, we learned during the exercise lab, ampersand, with the ampersand. What's the meaning of ampersand when you execute any command? Background and foreground. This is a background. Background means this child process will be running background, then this parent will be foreground. So wait is not the override such a way, then your parent process can do the other job. Also, today I'm going to introduce I probably mentioned the daemon process very briefly, and zombie process, and the orphan process. They are related to such a parent and child process relationship. If you do not understand this one, this will be the very, very practical situation when you learn, when you manage, when you are using the operating system after graduation, but slightly different. Some of them you can ignore. The others are critical to manage your operation. I will introduce this one later. So let's take a look at the real code that you are going to. This is the typical, the source code to create the processor. Very basic and very simple, but not easy first time to understand. If you never use a C program, it's okay. So you can follow the meaning, semantic of the command if you already did at least one program language. But I strongly suggest that this semester, not suggest, is required to get used to C or C++. I don't ask you to study C or C++ from the beginning. I think that you learned the C++ in the OP class, right? Then there's not much different. The only difference is if you are familiar with the IDE or for example, what is that? The Windows Visual Studio, try the command line interface. That's the only difference, okay? But nowadays, most of the developers are familiar with the graphical user interface, fancy, nice, convenient GUI, the base, the ID, but this time why don't you spend a little bit time to get used. But so this is the C program to create. At this time, not creating process only for. So this is a source code. As you can see, it's the main, and there is a command, the system library fork. Return of the fork is the process ID, which means right now this is the current process. Batch share is 100. So 100. If a fork is successfully completed, so process ID of the child process, let's say 101. Okay, then output of the fork is 101. So at this moment, so how can I say that this moment in terms of the microprocessor, the CPU, how do you know this moment or the location? Program counter using the PC. So let me use that PC. So this is the one process ID 100. Okay. Then the program counter is, let's say, after PID. Should be the number, but I'm using the command this time. So PID, the value of PID is what? 100 or 11? It should be 101. Okay? After this is successfully allocated, PID will be returned. Then, at this time, the PID 101 has the text area are shared exactly same code. Okay? This moment is the same thing. Then PID. Then this moment the program counter is the same thing. However, PID of this process is 0 because it's newly started. So it's exactly 2 copies of the instruction. Then they are running simultaneously from this time, after this. That's the most confused part. Okay? So running two set of them. Then let's follow the first the parent process, process ID 100. So let's check the PID. If before that, this time, if you cannot find the resource, no memory, so malloc is failed, then at that time, PID will be negative value. So let me quickly go back to change it. This one. So at this time, if the failed, so this is not created. Okay? If failed, PID will be -1. Okay? Something like that. Then in case of -1, so PID is -1, fork failed, and return 1, then parent either is done. Okay? This process will be, this program will be terminated. That's it. However, if successfully created, this will be 100. In case of 101, in case of 101, it goes to the parent else, right? So PID 0 else, which means this is the parent process. So what is the next job when you successfully the fork? We do not use the EXEC here. Okay? Wait. Okay, just wait until this one is completed. So it's waiting at this moment. The edge. Wait. So wait. Program counter is wait. At the same time, 2 processes are running simultaneously. Program counter is here, PID is 0 because it's newly. Actually, anyway, even though I shared the instruction, it's a new program. It's like you start the 2 program. Okay? Microsoft Word 2 times. So you are working for this, you are working for another job. So they are different. The sequence of the instruction. So after this, PID, okay, is nothing. Why? Because it's anyway new process. So PID is 0. That which means this is a child process. They are sharing same instruction but different thread, different way. So then that this time we can do the EXEC. So EXEC load this time the LS will be loaded into the text area. Then it will be to renew process. Okay? Then once the one is done, is the terminate and signal. Okay? And give the signal that who is waiting for the end of a child process, then continue this, then it's a return 0. It's done. Okay? So this is how it works. So to understand this, sometimes if you take a look at the homework, why don't you take a look at the homework? What if we fork 2-3 times? Okay? Always think about this copy of the instruction, continue the same program counter, okay, PC, but it will be different thread of instruction to be executed. Then you can follow, you can see how many processes will be created and figure out such a thing. Okay. Any question? Yes?
So when PID equal fork, so the parent process is 100, the child process is 101. So
Yes.
right now, after this command execute, PID equal fork, the PID is 101 or 0?
For the parent process, current process,
Yes.
so PID is 100. After fork, the PID value of the PID. Let's say this is not, it's a little bit confused than the A. Okay? A value is 101.
Okay.
Okay? Then this one has also A, but this one is not 101. Okay? After, while you are copying, at that time PID is not set. Okay? Once you copy the A equal to 0, because it's not copied, then once you complete to copy, then return the PID value from the fork, the command. Then this one will be 101. So from the 101 point of view, the A value is 0. Because of that, you can recognize which one is child process and which one is parent process. It's a little bit confused. So because of such a two-step of the process creating, as I said, that is because the creating process is actually most important part is you need to have the resource. Like when you move it, the new house, first you should have the house. So after contract, then you can move it, right? That's the two-step. Okay. Yes.
So after we just simply create the process, the child process is just created, the rest of the code will be first executed by the child process or the parent.
So
You said, I think
so-
the way you explained, you said parent.
you mean the parent process?
This code, the remaining code, like the if code.
Yeah, remaining code. It's the same thing.
Yeah, it's
Okay,
the same thing
then
in both
once
of them.
you exec, then code will be changing. Instruction code will be
Correct.
changing.
So when we copy, so it both will have the same
The
code.
copy means during the fork.
During
Actually,
the
it's
code.
not copy, share. Yeah.
Okay. So then who will run that code first? The parent or the child?
Both of them are the
Together.
executing. Yes. So it's once fork is successful, there are two processes. The 100 and 101.
Okay.
Okay. Then continue. If there is no exec, they are executing the same program. Okay. Until exec. But they are different process. Okay. Even though they are using the same instruction code, depending on the value, it can be different. Okay, so like the logic is using the PID. So because of the variable name, you got a little bit confused. Instead of PID, let's say this is a RLT PID. Okay, let's say RLT PID. Based on this value, there are three options. One is the error. This is less than 0 and equals 0, exec. And this one is the parent, the weight. This, based on the instruction of the PID 100, it will go to this one because the RLT PID is the 101. It's a positive value. But at the same time, the 101 is running, it's the same instruction code, So this time PID when you copy, actually not copy, when you share, okay? So PID value is 0. So it will go to this one. So you have the RLT PID for this is a child process. And exactly same thing, but RLT PID is 0, you go to this one. So don't be confused with this part. Okay, so this is the same thing for any operating system. However, sometimes, as you can see, so the EXE is followed by, the EXE is followed the fork always. So for example, Windows API, so has the system library at the creating process, but inside the to implement the creating process, that use the fork and EXE both of them. Okay, any question?
Yes. What the weight of null is doing there?
The weight of this one.
Yeah.
So this one is going to the parent process. Return ID is 101. So going to this one, right? During that time, weight of what? Termination of child process. Once child process complete this one, return 0 and inform to the parent process. Then wait is done and continue the next instruction. That will be the return 0.
So that means both are not executing simultaneously, right?
Excuse me?
Both are not sharing the resources, right? Because
Oh no, not sharing the resource. The only sharing the resource is during the fork, before, after fork, before EXEC. That is the text part. Text part is shared. Sharing does not mean the same logic of instruction. Okay? So they are sharing the same logic, but that doesn't mean that it's the same branch you use. Depending on the value, return RLT PID. So it will go to this one, child go to this one, something like that. Okay? It's the same logic, same the instruction, but because of the value RLT PID, so it will go to the different logic. Okay? Yes.
So in the parent process, you say wait and then you put null. You always have to
Where is
put
the
null.
null?
And you
Null.
No, so I do not. That's the kind of the checking whether any return value or something like that. But you can check the details of the argument from the manual page and the documentation. So, but the most important part is what is the meaning of the fork and EXEC. Please follow. To understand this one, you'd better have the knowledge of microprocessor assembly a little bit. Not the assembly command by command, but how CPU is working. Okay, so it use the program counter, then location, and get the copy, the move, the instruction, next instruction, something like that. So these are the set of instruction in the text area. Then they share until the EXEC. Because of that, so they are running concurrently, but different semantic of running, even though they are sharing the same instruction code. Okay, so best way practice. So during the exercise lab, you will create the process several times, but you can see which one each part will be used in the child process when I focus several times, how it works. Okay, then same thing in the Windows API. Instead, this create process the system library includes both the fork and EXE, but it's the same. Then finally we can have the process that I showed you last time. Then this is the way I explained the way the parent is waiting. Okay. Then, however, what if the problem is parent process is terminated forcibly? Okay, sometimes forcibly terminated. I will show you how to forcibly terminate. So later, the next slide. But suppose that the parent process is terminated forcibly. Then child process, most of the case, automatically terminated. Because no parent, so there's nothing to be returned the end of process. So it's the cascade terminate. It's called the cascading terminating. However, sometimes, one more thing. There is one thing. When you terminate, actually, do you remember what is the PCB? Process control block, which is the data structure that keeps all the information about the process by the operating system. So when you create the process like the 5 stage, so this is the new, this is the ready. So what is the new state? It's not ready, but ready means you are ready to get the CPU resource. That doesn't mean, so it is when you click, double click, it's right away. No, you need to find the resource. And one of the job the operating system need to do is PCB, to create the PCB for the new process. Okay, and this is kind of table, process table. So new process like the 101 will be registered in the table process list. Then it has the information about not all the copy of process instead of PCB data structure. Okay, then this one will be the new state. After that, it will be the ready. Okay, to be executed by the CPU. But similarly, when you terminate, what happened when process is done? What if when you leave the library? So you occupy the one space in the library, then you are done. So when you leave, you inform to the librarian, then I'm done, and then somebody can use your seat or your room. Similarly, when you terminate, you need to inform to the operating system, then revoke, free all the resource, because the main job of the operating system is the resource. Okay, how to maximize the resource, the utilization, and the fair. So you need to inform to the operating system, then operating system free all the resource, then finally this one will be removed. Okay. However, when you terminate, okay, this time, so when you terminate, when you are done the last instruction, actually your process is not doing anything, right? And then resource is geolocated, free. The memory space and any file you reserve will be free. Then, before the takeout, remove this list from the PCB table. There's a short amount of time. There's information on the PCB, but there's actually there's no resource on the memory, right? So this is timeline, and last instruction is done. And during that time, you free up all the resource. And this time, you remove the list from the PCB table. At this moment, your name is on the PCB, but it's not physically located. Physically allocated. This is called zombie process. Zombie means it's not existing, right? So there's a new movie recently, right? Horror movie regarding zombie. I'm not sure, but the zombie means it's kind of ghost. It's ghost, right? It's not existing, but we call it, right? So same thing. Process the resource. There's no such a memory or the file, but name is registered on the PCB. So this is called zombie process. It's a short amount of time. So, question. Does the zombie process hurt your operating system or not?
No.
So sometimes you can find such a zombie process. It's called a really zombie, some of the operating system. Really, when you process PS-EF, you can see such a zombie process. So, is it hurt or not? 99.99% you can ignore the zombie process, because So zombie actually does not exist, which means it doesn't hurt. The reason why it's called zombie is it's on the process, the table. Okay. So your name is registered in the list 100 times, but so really there exists available seats in the library, so somebody can use them. Okay. So even though you have the zombie process, what you need to do is most of the time wait, then it will be gone. But very, very rare case, intentionally somebody create a lot of them and the terminate. So your PCB is overflow. That's the only problem. So at that time you need to sometimes forcefully remove such a list. That's the only. It's a very, very rare case. But the most of the time you can ignore the zombie. There is another similar process, open process, orphanage. What is orphanage? Orphan, no parents. Okay, so which means open process is unexpectedly, so without the intention. This relationship is broken, disconnected. So there's no return, and so this way it processes. So there's kind of something unusual thing happen. Then this one is running, keep running, keep running. Okay, sometimes not running, but it occupies the memory resource. Even though end of the PC, there's no parent to receive the end of termination. So it will not be terminated. At the time, this one is called open process. Open process hurt the performance or not?
Yes.
Yes, definitely. You need to take care. As an administrator, open process should be. So sometimes the open process is the parent ID is 1. Okay? It's a parent process ID 1 and it's running. Then at this time, you should be careful. There's another process that I explained, daemon process. What is a daemon process?
It gives you the log of all the processes that is running.
So, daemon process like what is the example of the daemon process? Web server. Okay? So, for example, what kind of web server are you using? IIS or the Apache? So, have you ever started the Apache web server manually? So, you can start Apache start. So, you can start there are several. For example, default is 5 or 6. The Apache process will be running. At that time, when you check the parent, so I start the Apache web server, but when you check the parent of that Apache web server is 1. Your kernel take care, because when I start, he's started, so firstly, but I want to enjoy my time. I don't want to wait until he finishes his study. Then ask the admin or something librarian to take care of his whatever. So your parent will be kernel process, not me. So I